Hello and welcome to Color Multimedia Enterprises. My name is Luke, also known as Tienere, and in this tutorial we're going to take a look at basic collision detection, as you can see, and we will be taking a look at not necessarily perfecting it, but it is going to just be a little something to get on the road of being able to just move around the map and not being able to move over walls. So without further ado, let's get started. Okay, so as mentioned in the previous tutorial, introductory tutorial even, introductory video, what am I talking about? I don't even know. So yeah, as mentioned in the introductory video, what we will be taking a look at in this tutorial, when I get my words finally correct, we are going to be taking a look at being able to use few things in order to allow us to get collision detection correct. And in order to do that, what I'm going to do is I'm going to go into the assets folder and just take a look back at our dungeontiles.json file, I believe. So let's just cd out of here and then cd into assets, where we will be able to find our dungeon tiles. So that'll be dungeontiles.json, like that. No, I do not want to save it. So here we are in our JSON file. So if you remember back a couple of episodes ago, we had this file here. I'm going to add a new property and I'm going to call it passable. Right, so we're going to have a few passables and not a few passables, so we're going to have passable false for the walls, and we're going to say that the floors are passable because that just makes complete sense. And once we have done with that, I'm just going to save that. And in order to, let's say, get these passables working, we're going to obviously store them somewhere. So the first thing I'm going to do is create a few more variables in our tile map. So we're going to say passable tiles, which is going to be an array of booleans, which is where we are going to store our passables. And then I'm also going to add another one, which is going to be passable cells, which is going to be of type array, of type array, of type ball, right? Now, if you don't know, what this is doing is it's basically saying, okay, this is a multi-dimensional array. We're storing an array of booleans inside an array, if that makes sense. So before we can actually use it, we're going to have to initialize it. So let's go here and say passable tiles is equal to an empty array. That's what that basically means. And passable cells, again, like that. So when we initialize it, the first thing that I want to do is I want to say, okay, passable tiles dot push, and then I just want to say tile info dot passable, right? So all that's doing is it's saying go into the information, which is what we're grabbing from here, right? We're getting this property here, which is going to be false, and we're storing it inside this passable tiles function here. Now when we draw the map from CSV, which is what we're primarily using, we're going to have to store it in a way so that we can say, okay, can we go up, can we go down, can we go left, can we go right with our player as we're moving it along the screen. So in order to do that, which is why we've initialized this variable here, passable cells, we're going to determine whether or not we can pass through that particular cell when we move up, down, left or right. So I'm just going to quickly take a look at my previous file. So what I'm going to do in order to get this done is for each row I want to initialize and store a variety of booleans in an array. In that I want to if the value is greater than -1, what I want to do is values.push, oops, and in here I want to say passable tiles, which is what we referenced earlier. And what I want to do is I want to convert our value, which we grabbed from here. If you remember in the previous tutorial, in our tile map tutorial, we take the value of whichever column is the ID, right? And we want to then +1 onto that, so that as to make sure that we are referencing that. And now that I remember, we also do need to add passable tiles dot push false. Now the reason why we're doing that is because if we go back to our, not this one, if I open, which one was it? 2 seconds. If I were to open, yeah, dungeon map.json. No, I do not want to. So if we see here, we've got all these -1s. If we were to just not pass false in for the first time, we're basically not taking into account that -1. So that's what I want to do. I want to take into account that -1, and in order to actually take it into account here as well, I need to first +1 so that we can actually get to the passable tiles index that we actually want, which in this case is going to be, let's say if we have 0, for example, because we're taking into account -1, right? We need to add 1 to it in order to account for that. If that makes any sense. If it doesn't, then you'll notice why. So we'll go back to here. What I'm going to do is say continue. The reason why is because I don't want it to then say, okay, pass in another value which is going to be false, because if you see here, we're saying, okay, if it's greater than -1, then we want to push a value that is going to be either 0, 1 or 2. Otherwise, it's going to be false, if you see here. So we're grabbing the index from passable tiles and we're passing it in as a Boolean value. Then what I want to do is after every row or column that we've after every column that we've done, we want to then push those values into passable cells. So that is essentially, we create an array of booleans, push some values in there, and then we push those array of booleans into passable cells, right? So now that we've done that, what we can then do is we can think about actually determining whether or not the player can go up, down, left or right. So I'm going to create some more functions in here to actually do that. Now, I'm not going to go into too much detail because it's fairly self-explanatory, but what I'm going to do is just copy and paste from a previous file that I was testing this on, and just copy and paste that in. So we've got can go up, can go left, can go right, and can go down, and that's taking a tile X and a tile Y. Now, in order to know whether we can go right, left, down, or whatever, we need to be able to determine whether or not, if you can see here, we can go left, right, up or down. So we're guessing the current tile X and we get the current tile Y that our player is on. We pass it in, and if tile Y is going to be greater than the length of passable cells, then we know we're going to pass false, because that's the limit that our world is at, if that makes sense. The same goes for this one here. If we're at cell 0, then we know that tile Y, that we are at the start of the world. We don't want to go any further that way, if that makes sense. So now that we've done that, we can now go onto our player class and actually start implementing this sort of collision thing going on. So in our update class, what we want is we want our map reference, which we've got here. So once we've got our map reference, we can then actually go ahead and do our detection, or detecting whether or not we can actually go up, down, left or right. So let's go into isKeyDown and apply that method. So what I'm going to do is I'm going to say if mapref dot can go up, and I'm going to pass in current tile X and current tile Y. If we can go up, then what we want to do is we want to just say, okay, anim.y is equal to y, because we know that just from this, y minus equals delta time times speed. We know that when we do reference that, we know that we can then set the animation to be that. If that makes sense. Then what I want to do is I want to say if not y plus 5, because if you remember in our previous tutorial I was talking about, okay, our player is slightly higher than 32 by 32, is actually 32 by 36. We're plussing 5 to give it a little bit of leeway from the top of the actual player animation down to the actual size that it should be. So we're going to take that into account. We're going to get current tile Y multiplied by mapref.cellHeight. So if we're not going to be going any higher than our current tile Y times that, if we cannot go up, right, because we're checking to see if we can go up or not. If we can't go up, then we know that the Y location cannot go any higher than the current tile Y multiplied by our cell height. So we're actually getting the pixel value there. And then what we're going to say is if anim Y is equal to Y, anim Y is equal to Y, if that is not the case, right? If it is the case, then we just want to say, okay, Y is equal to anim.y. Because because the animation will stay in place, so we're just going to say, okay, the Y pixel of the animation is going to be, this Y location is going to be set to the Y location of our animation. Even. So we're going to do pretty much the same for the rest of them. So again, I'm just going to copy and paste to save time. Like this. Just going to get rid of it. Do the same for A for when we're going up, and the same for when we go right, not left even for the other one. Like that. So as you can see, we're doing the check, can go right, can go up, can go down. Hang on. Let's do it properly. There we go. Right. So now that we've got that, what we can then do is check to see if we've got everything right. So that should be fine, I believe. So if I just save that now. Don't think we need to do anything with main.hx, which is our file here. I don't believe we need to do anything with this. So now the case is just to test it to see if that is the case. So let's go into our folder, which is in fact on our desktop. I can let me just move this over here so that you don't know what I'm doing. Okay. So let's go into our folder, command prompt, Open that up. I'm going to do Hexlib run, OpenFL, build project, and we're going to build to Nico, because that is the fastest target to build to. Well, with the exception of Flash, but we're not going to be targeting Flash. I forgot. So we need to identifiers for bottom and right, which is fairly simple. It's not a difficult implementation to do. So if we go up here, what I'm going to do is I'm going to say public var left. I'm going to say get and null, so it's just going to be a getting property. This is going to be of type float, and here all I'm going to say is if function get left, we're going to return. Did we say? Did I say? What did I say? So with the left, all I'm going to do is just say x plus anim.width. Again, when I can type. And then we're going to do the same for bottom as well. It's going to be get null. It's going to be of type float. Now it's going to be function get bottom. And we're going to return y plus anim.height. As you can probably tell, all we're doing is we're adding the y location with the height of the animation, which will get us our bottom of the animation and the left of the animation respectively. So again, I'm just going to save this. Going to go back to command prompt, do the same thing. Then that all should be fine. Once we've done that, we can then of course test to see if everything's all good. Okay. Did I misspell it? Oh, called it left for some reason. No, it's supposed to be right. Right, so that should all be fine now. Which it is. Okay, so now what let me try that again. So now what we're going to do is actually check to see if everything's all good, which it should be, because I know I've tested it before and it should be working. So let's take a look. Obviously it's going to go onto this screen first. So as you can see, we're moving up, left, down and right. Let's go right. Okay, I cannot go any further. As you can see, the player is animating and I cannot go any further than that. Now as you can see, it's not quite perfect. You can sort of go down that way, but what we can't do is go off the walls, as you can tell. So now I can go up here. I cannot go. Oh great, I'm stuck. As you can tell, it's not perfect, that is weird. Why did that happen? The ceiling math isn't really a good idea either, if I may be honest. Excuse me? So let's try going up here. Now the reason why the ceiling math isn't perfect is because we can go this way. As soon as I go slightly over the border of the tile, I can now go up, because it assumes that I'm actually within that tile, right? But as soon as I go slightly over this border, it assumes that I'm now in this tile, and now I can't go any further. So that's something that we that we do need to fix. We either need to seal it if we're more into the left side of the tile. If the leftmost part of our player animation is within the left part of the tile, then we assume that that's the tile that the player is in. Otherwise it's in the right side of the tile, if that makes any sense. So that's something that we do need to actually sort out. I didn't actually manage to get around to doing that yesterday, so let's go ahead and try to do that. So, and bear with me because I'm not very good at maths, if I may be honest. I did get a B on my GCSEs, but that's not great. But nevertheless, let's attempt to do so. So in order to do that, what we're going to do is we're going to get our animation width, right? So we want to get our width and determine whether or not the leftmost part of our animation is in the cell that we're currently in, if that makes sense. That probably won't work, but we're going to try it anyway. So what I'm going to do is I'm going to say var x, no, let's just say x pos, x divided by map ref cell height, cell width, right? So we want to get its current location anyway and determine what that location is. So we know that this is going to be a float. Now what I'm going to do is I'm going to check to see if this is greater than 0.5 or whatever it might be. So what I'm going to do is I'm going to then divide that by 2. So I'm going to say if x pos divided by 2 is greater than, then I'm going to say math.seal x pos divided by 2. So let's do math.round. So essentially what's happening here is I'm saying, okay, if the x position, so we're getting the float first, so we know whether it's going to be higher than a 0.5 within its decimal number or whether it's less than. If it's greater than 0.5 and the round goes down, then we know that the location of the player should be to floor the value. So we're going to floor it instead, right? Otherwise, we're going to seal it. So I'm going to say math.floor there. Otherwise, I'm going to say math.seal here. And we're going to do the same for this one. So I'm going to say var y pos is equal to y divided by map ref dot cell height. Again, when I can type. We're going to round the y position divided by 2 and check to see if that is greater than if we were to seal it, divided by 2. Then we're going to return, and we're going to say current tile y is equal to, for God's sake type, is equal to math dot floor y divided by, in fact I'm just going to copy and paste the rest, why not, let's do that. else do that. Why is it doing that for? Right, so let's save that. Test it again. Oh, great. Here we go. Missing semicolon. Where's that? Oh, there. Okay, save that. That's probably the reason why there's all the other errors. Most likely. So that should be fine. Eventually. Okay, so now let's test it and see if that actually is correct. So, I'm going to go this way. No, can't do that, can't do that, can't do that. Obviously this is still causing the error, but let's just go down here. I cannot go any further than that, can't go any further. Oh. No, not quite. And yeah, it's still not perfect. Yeah, I'm not entirely sure. But yeah, thank you very much for watching. I hope you enjoyed. That was a take a look at map collisions, and I will see you next time.